Okay, let's solve the radical equation. Remember, this one is isolated, this one is not isolated, but if I move the one to the left side, then this one will be isolated and this radical will no longer be alone. So no matter what, this minus 1 kind of throws us off and stays there, but in any case, since one of the radicals is alone, we will go ahead and square both sides. And when we do that, this disappears and we get x minus 1. However, on the right, notice I have two binomial looking things that I need to distribute and multiply. So I have first times both, second times both. So root x plus 4 times root x plus 4 minus 1 times root x plus 4 minus another 1 x plus 4 under the radical, and then plus 1. So these guys combine and become negative 2 of the radicals. Bring down the plus 1, and these guys just pop out the inside again. For every two identical ones, this is like basically this case where you have the whole thing squared, equals x minus 1. So now I'm going to combine like terms on the right side. It looks like these guys can add up to a positive 5, and then I have minus 2 square root of x plus 4. Then I'm going to isolate and get the radical by itself. So when I do that nicely, these guys go away. I get negative 6 equals negative 2 radical x plus 4. Now at this point, since it nicely divides out evenly, I'm going to divide that out, get the radical all by itself, and I get 3 equals that. Finally, I'm able to square both sides again, and in doing so, I get 9 equals x plus 4. I subtract 4 from both sides, and we think x is equal to 5. But we have to go back to the top and check x equals 5 and see if it works in the original problem. So 5 minus 1, is that equal to 5 plus 4 minus 1? That's going to give me a 4, which is going to pop out a 2. That's going to give me a 9, which is going to pop out a 3. And then I have the minus 1, and it looks like 3 minus 1 is 2. So x equals 5 checks out, and our solution is x equals 5. Our next idea is solving equations of the form x to some power equals a number. So for example, let's say x squared equals 9, or we have something like x cubed equals 8. So some power equals a number, x to some power equals a number. So we make use of square roots and cube roots. So for the first case, if we have to solve x squared equals 9, we can do it two different ways, either by factoring or by using the square root property. So let's go look at what the square root property says. It says that anytime I have something squared equals a number, I can square root both sides and extract those roots, and it'll either be a positive or a negative of the square root of that number. So in the case of solve x squared equals 9, we can take square root of both sides, and then x can either be plus or minus 3. So there's really two solutions, since if I check, 3 squared is equal to 9, and negative 3 squared is also equal to 9. If I want to solve x cubed equals 8, which was given as an example here, I can use the same idea for cube roots and say I'm going to take cube root of both sides. So x is going to be equal to either cube root of x cubed is just x equals, and then cube root of 8 is 2. Now I don't need to include plus or minus for this one, since if you check your solution, 2 cubed is equal to 8. If I try a negative 2 cubed is actually going to be negative 8. So the positive or negative you have to account for applies to square roots or even roots. If it's an odd exponent, if you're taking odd roots, then the answer will always match up what the sign of the original one was. So again, notice I have a z squared in this case, so I'm going to divide both sides by 2 and get the squared quantity alone. Once I do that, I can just make use of the square root property and say my answer is plus or minus 10. So again, our goal here is that we want to have something squared equals a number. Something squared equals a number. Now part B also matches this. I can square root both sides, and for every two of these identical binomials, one of them pops out. So I get plus or minus 9. And I basically have two equations. T minus 5 is equal to 9, or t minus 5 is equal to negative 9. And then I can add the 5 and get t equals 14 for one of my answers, and t equals negative 4 for my other one. Now part C, since I always want this going on, I want to get this guy alone, so I'm going to subtract 1 from both sides. I get 3x minus 6 squared equals 25. Now I'm ready to square root both sides, so I get 3x minus 6 equals plus or minus 5. And that's going to give me two possible equations. 3x minus 6 equals 5, 3x minus 6 equals negative 5, and then I solve each. And in solving both equations, it looks like I get x equals 11 halves and x equals 11 over 3, and x equals 1/3. The last idea we're going to look at is the Pythagorean theorem, which relates the three sides of a right triangle. Again, the triangle has to have a 90-degree angle, and C is always the longest side, or the hypotenuse. So it doesn't matter how you label A and B, but C is always the one across the longest side, and it's called the hypotenuse across the 90-degree angle, of course. So let's go look at a couple of examples. We have the two sides A and B, known as 4 and 4. We want to know what the last side C is. So we have 4 squared plus another 4 squared equals C squared. That's going to give me 16 plus 16 equals C squared, which is 32 equals C squared. Now if I want to know what C is, it looks like I have to make use of that square root property. Square root both sides, and we get C equals square root of 32. Now again, it's plus or minus, but since we're dealing with length, we ignore the negative one. So C is just going to be square root of positive 32, and while we're at it, let's go ahead and simplify that as 16 times 2. So we can split that and get C equals a positive 4 square root of 2 is how long the third side, or the hypotenuse, of this triangle is. Now let's go do part B. This time we don't know A, we do know B is 6, given here, this must be B. And on the right side, the formula says should be C squared. So C in this case, according to the picture, is 10. That'll be A squared plus 36 equals 100. Now let's isolate the A squared and see what happens. A squared equals 64. And again, I can square root both sides and get A equals plus or minus 8. But since it's a length, I'm gonna keep the positive only. So A is going to be 8 units in this case. So the other side of the triangle is 8. It looks a little bit off. It really should be longer since this is 6. Let's look at an application. It says a guy wire attached to the top of a 30-foot pole is anchored at 10 feet from the base of the pole. Find the length of the guy wire. So we don't know how long that is. We know this must be a 90-degree angle. So that's like our C. So let's use the Pythagorean formula or theorem. A we can say is 10, B we can say is 30. So 10 squared, 30 squared must be L squared in this case. That's going to be 100 plus 900 equals L squared. So 1000 is equal to L squared, and again we can square root both sides, and L is equal to plus or minus square root of 1000, but we're only going to keep the positive. So L equals square root of 1000, which is going to be approximately, using your calculator, 31.6 feet. So the guy wire is actually 31.6 feet long. Let's look at another application. It says when a skydiver initially falls from an airplane, the velocity v they reach in miles per hour after free falling d feet can be approximated by this formula. So the formula we're dealing with is given, and we know v is in miles per hour, which is the velocity, and d is in feet, which is the distance they're going to free fall. How far do skydivers need to fall to attain the following velocities? So A, we're given 60 miles per hour. We need to find how far they fall, so that must be our D that we're looking for. So let's take 60 miles per hour and put it in place of the V, and then solve that resulting equation. So I'm going to multiply both sides by 11, I guess, since I don't like that denominator. That's going to give me 11 times 60 equals 60 square root of d. And then I'm going to go ahead and divide both sides by 60. Why not? To make the 60s go away. So we end up with 11 equals square root of d. Now since this is a radical equation, I can go ahead and square both sides and get d equals, looks like 121. And since we're dealing with feet, so 121 feet is how far they will free fall at 60 miles per hour. We'll do the same thing for part B. It's 100 miles per hour, so I go into my velocity equation and I put in 100 miles per hour. Then I solve the result. So multiply both sides by 11, then divide by 60. Now I'm ready to square both sides. And once I do that, I get d is equal to about 336.111, so we'll just say about d, 336 feet, is how far they will free fall if the velocity is 100 miles per hour. So I want to give you a quick reminder at the end of the section about radical equations and then quadratic equations, because we looked at both in this section. Please don't confuse the two. If there's a radical involved, you're going to square both sides to get rid of the radical, so you'll end up with x equals whatever that number may be. Versus if you have a quadratic equation, you're going to undo that by square rooting both sides. And when you do that, you're going to end up with a lower exponent. It's going to knock down the power to an x equals plus or minus whatever the square root of that number is. So don't confuse the two, please. In one of them, you're looking at a radical equation, so you employ squaring both sides. In the other one, you're looking at a quadratic equation and you square root both sides, and whenever you square root both sides, you're going to create a positive and a negative for your answer.